Hi everyone, my name is Phil Strain. I'm a 41-year-old male with white hair and a speckled grey beard with glasses, and I'm very excited to have the opportunity today to present Miro's approach to accessibility at OxCon along with my colleague Stefano Baldan. So my journey with accessibility began when I was 4 years old, when my next door neighbor was born with a visual impairment, and I really experienced what it was like for her to grow up in a society that excluded people with disabilities. But I also saw the huge impact, the positive impact that technology had in her life. And so I've always been drawn towards ways of removing the barriers through technology that prevent people from participating fully in society. For example, in 2004, I undertook a Ph.D. in human-computer interaction that explored ways of communicating spatial information to blind and visually impaired web users through the use of speech, non-speech audio, and haptics. And this led to a full-time role at Google, where I conducted the first user research with visually impaired users that led to improvements to google.com and the Google search results page, and improvements such as the addition of headers that are still used today. And I was also fortunate to drive accessibility efforts at Apple from an iOS perspective, where I wrote the internal iOS guidelines, and then at Spotify driving a huge transformation program that led to Spotify building and focusing on its first accessibility team. So I've been really fortunate to have all these experiences in my career, but I can really truly say that both the challenge and the opportunity that we face at Miro to make a visual collaboration tool accessible to everyone is one of the most difficult and exciting challenges in the accessibility space today. So I'd like to start off by talking about what is Miro. So we describe Miro as a visual collaboration tool, and it's used by more than 50 million people around the world to run engaging meetings, brainstorm big ideas, and to design new products. So we empower distributed teams to collaborate across formats, tools, channels, and time zones without the constraints of physical location, meeting space, and whiteboards. And at Miro, our mission is to empower teams to create the next big thing by providing the best solutions for collaboration. And some of the use cases we have for Miro include brainstorming. So we provide tools like sticky notes, where you can add a sticky note to a whiteboard. We have images, and we have other things as well that will allow Miro to collaborate. And then we have meetings and workshops. So the goal for meetings and workshop is to allow anyone anywhere to collaborate. And just to iterate how powerful Miro is and how widely adopted Miro is, 99% of the Fortune 100 are customers. It's the #1 collaboration platform. We have 50 million users all around the world, hundreds of integrations with technology partners, along with enterprise readiness programs such as security readiness. But for our team, one of the most important things is that we understand that teams include people of all sorts of different backgrounds, experiences, and access needs. And so what we do, we strive to give everyone an opportunity to collaborate. So how do we approach accessibility for such a project such as Miro? So the first step is to lay the foundations. And so what we're going to talk about now is how we think about laying the foundations for our accessibility program at Miro. So the very first thing and the very first step for any accessibility program is to think about compliance. So what do we mean by compliance? The W3C have published the Web Content Accessibility Guidelines, currently at 2.1, which propose the content be perceivable, operable, understandable, and robust. To determine how compliant Miro was with WCAG 2.1 AA, we conducted an independent third-party audit with one of the leading accessibility consultancies. And this audit revealed over 300 accessibility issues with our product. We set up a program to remediate these issues, and as of today, we fixed over 95% of the issues raised in the audit. And this enabled us to create our first accessibility conformance report based on the voluntary product accessibility template, which is published on our website at miro.com/accessibility. However, we also acknowledge that there's multiple other guidelines that are available. So for example, we have the HECVAT, the Higher Education Community Vendor Assessment Toolkit. And the reason I'm calling this out is that this is an excellent set of questions that accompany this toolkit that should be considered as part of any accessibility program. So for example, has a third party conducted an audit? Do you have a process for verifying compliance? What about technical or legal standards? Do you have an accessibility roadmap? Training and accessibility, documented process for tracking issues, accessibility as part of your software development lifecycle, do you have keyboard accessibility in place? And do you not have a separate version of your app? All of these things are really, really great questions that are vital for a really successful accessibility program. And so in addition to industry standards like WCAG, Miro is also aware of additional procurement policies that are provided by individual companies. For example, the BBC provides an excellent guide to accessibility requirements, which go far further than WCAG to clearly define assistive technologies that should be supported from a usability perspective. And so this policy is intended to move from just compliance towards a more inclusive approach. So what we have here is a table that outlines the different types of assistive technologies that vendors supplying the BBC are expected to work with. So for example, we have JAWS, Zoom Text, Fusion, iOS built-in accessibility features, Mac OS, and Dragon speech recognition. And so this is a really important step, that you actually test your product with assistive technologies that are used by your end users. And then as a final mention, we have emerging guidelines around collaborative tools, such as the collaborative tools accessibility user requirements that is provided by the W3C. So I mentioned before that Miro had a huge audit done, and we've heard recommendations that you get an audit done once per year. However, we feel it's not a great idea to have a big bang audit that reveals hundreds or even thousands of issues. It's much better to have a continuous program for addressing accessibility. So, for example, what you can easily get caught into is what we call this audit remediation loop. So you do an audit, find hundreds of issues, you fix all the issues, and then a year later, you do another audit, find hundreds of issues, and so it's a continuous cycle. So it's much better to have accessibility embedded as part of the culture of your company. So at Miro, what we've done, we've defined an accessibility policy. We've integrated accessibility throughout our product development lifecycle through the creation of non-functional requirements that every product manager has to follow at each stage of the product development lifecycle. So for example, at the requirement stage, accessibility should be considered and included as part of the planning process. At the design phase, there's lots of things that you can do to ensure that you're not introducing accessibility issues, and we go through an audit with our accessibility designer. And then at the development stage, it's important that engineers are educated into how to create accessible experiences. And also QA is really important as part of this. There's different types of QA, but a combination of both manual and automated accessibility testing is important. The other thing then, so what we have then that should really underpin any accessibility program is education and training. But for me personally, one of the most important things is that we include people with disabilities right throughout our product development lifecycle. And for me, user research is absolutely critical to that. And it's really powerful if you bring people in. It can help so much to help build empathy. It can help highlight issues that may not be brought up with WCAG. And it just really helps drive forward your accessibility efforts so that you're actually creating awesome experiences for people rather than just sticking to compliance. And the other thing that I just want to highlight, we've built a really awesome team of people that are focused 100% on accessibility. So I believe accessibility should be everyone's role, but such is the challenge that we have at Miro, we have invested in the team. So we have people like Jens, our engineering manager, Kai, our accessibility designer, Stefano, Marcin, Adrian, and Lene, engineering. And we're very excited to welcome Peter in April, who will be leading our accessibility QA efforts. So just to recap, compliance with WCAG is absolutely an important part of any accessibility program, but it's really only the first step, and it's really important that we consider other aspects as well. We also have an accessibility program that ensures that we shift left accessibility at every step of the journey. So you may have noticed that we've covered the first two parts of this talk, compliance and sustainability, in around 10 minutes. And that's because the real focus in our team is on accessibility innovation. We have a really exciting opportunity to unlock collaboration for everyone. And so the main focus of our talk is going to be how we approach this. So if I just move to the next part of our talk, which is really around accessibility innovation. So how do we create experiences and how do we create a collaboration tool that works for everyone? So whenever I first joined Miro, I heard a lot of feedback on Twitter and other sources that collaboration tools are inherently inaccessible because of their spatial nature. And having been involved in this technology space for around 25 years, it reminded me of conversations that we've had in part around accessibility and the evolution of user interfaces. So for example, interfaces used to be command line based. So things like Emacs and MS-DOS provided a very linear, straightforward interface to navigate. And even today, I know visually impaired users who solely use Emacs speak. However, with the introduction of Windows 95, a spatial graphical user interface, there's lots of concerns from the community around accessibility. However, with the addition of accessibility APIs and a lot of iteration, today operating systems like Windows and Mac OS are fully accessible. And again, the second example is whenever the iPhone was introduced, Apple removed the physical keyboard and replaced it with a software keyboard. Again, there was a lot of concern from the community, but Apple really innovated on the experience with VoiceOver, with touch to explore and spatial navigation. And our latest web survey found that 90% of respondents use a screen reader on a mobile device. I really love this quote from Stevie Wonder. There's nothing that you can do that I can't do on an iPhone or iPad. And I would like to propose that for visual collaboration tools such as Miro, there's no reason why we cannot make these tools fully accessible to everyone. And to take this idea just a step further, by focusing on creating awesome experiences for people with disabilities, by innovating in this space, we can create experiences that will be amazing for everyone. And so just to be really clear, on our accessibility team at Miro, our focus is on the experience for people with disabilities, but we really believe we will improve the user experience for everyone. And so I know this is a mantra that's oft repeated, and sometimes it's been hard to find demonstrations of this, but today I'm very excited to introduce one of our accessibility engineers, Stefano, who has been driving forward some of the accessibility initiatives at Miro. And so he's going to outline 3 examples of how innovating in accessibility at Miro will benefit everyone. So over to Stefano.
Thank you very much, Phil. My name is Stefano, and I'm a man in the mid-30s with short brown hair and brown eyes. Today, I would like to introduce to you some of the technical challenges that we're facing at Miro in order to make our boards accessible. So the first example would be keyboard accessibility. Keyboard accessibility is a fundamental aspect of accessibility of the boards in general, because by making our content keyboard accessible, we basically provide one more tool, one more way to operate with the widgets and with the contents of our board without the need to use a mouse or another pointing device. And that, of course, is a fundamental aspect because it allows people that cannot use a mouse or another pointing device for all sorts of reasons, including visual impairments or motor impairments, but also we allow people that prefer to use the keyboard over the mouse to just access the objects in another way that doesn't require a pointing device. So the main concept or like the inspiration that we take when we tackle accessibility at Miro is thinking that we stand on the shoulder of giants, and luckily for us, there are already a lot of standards and guidelines and best practices in order to navigate and make traditional web content accessible. Unfortunately, our product is heavily based on the HTML canvas for performance reasons, for reasons of flexibility with rendering and so on and so forth. And therefore, the problem with the HTML canvas is that basically not being HTML elements, but just the pixels rendered on the screen, the browser doesn't know anything about the objects that are rendered on the screen. And therefore, we've got no semantic information, and we need to basically recreate and reproduce everything that a browser can do on its own in terms of keyboard navigation with a custom solution. We need to re-implement everything ourselves. And when doing that, we are taking heavy inspiration from the guidelines and principles that are already available for web content, and we are tweaking them to better suit our needs. So whenever you think about web pages, we can recognize 2 main ways of navigating through a web page, through the contents. Probably the most obvious is just object by object in a linear fashion. But when the page grows in size, then it's pretty inconvenient to just go one element after the other, because then at that point, the elements become too much. And therefore, sometimes, or most of the time actually, in order to navigate these complex web pages, we take advantage of the hierarchical information that is embedded into the pages themselves. And what's used the most is headings and titles of different levels. So another way of navigating through a web page is just jumping to key information and key sections of the page by using such headers. On top of that, we've got a key difference, a structural difference of our product with respect to a web page. And the key difference is that we, like the Miro board, is an indefinitely extensible and infinite 2D space. It's an infinite canvas where content can be placed in an absolute free-form way. So there is no fixed layout. There are no rows, no columns. Objects can just be placed wherever. There can be overlaps. It's completely free-form. It's literally like putting sticky notes on a whiteboard. So in such an environment, in addition to linear and hierarchical navigation, we want to have another way to navigate objects. So we want to take advantage of the spatial nature of this product, and we want to navigate spatially. So we want to reach the objects starting from a starting point. We want to reach the closest object in a specific direction. So we want to reach the closest object to the left or to the right or to the top or to the bottom. So in such a fuzzy 2D space, how do we solve a linear navigation? We've got a problem here. We've got this 2D space, completely free-form, with no alignment, no layout whatsoever, and we need to transform this into a list, which is basically one dimension. We need to linearize this fuzzy 2D space. So in this slide, there is a picture that represents exactly this concept. On the top of the picture, there is a bunch of slides, which are arranged in the 2D space in a fuzzy fashion. And then at the bottom of the picture, there's a list of the same widgets ordered in some sort of way that makes sense. So this ordering is the fundamental problem and the fundamental challenge. We tried a couple of simple solutions, which was using the creation time of the widget to enforce the sorting or the unique ID of the objects that we have in the system. But unfortunately, this doesn't work because they have, like, these properties have no relation whatsoever with displacement and with the structural, like with the distribution in space of these widgets. And so the result is that when we navigate linearly through the widgets using the creation time, for example, we've got a lot of jumps across the board in apparently random places. And this is very, very counterintuitive also for people with low or no vision, but this is especially frustrating and counterintuitive for people that actually can see what's happening on the board. So the user feedback that we had from both sighted and non-sighted users is that the most intuitive way to rearrange these widgets would be following the natural reading order. So for Western cultures, at least, from the left to the right, and then from the top to the bottom. If the objects were aligned on the grid, that would be an easy thing, because we would just need to sort all of the objects by the vertical axis, and then group all of the objects that have the same vertical value, and then sort the groups by the horizontal axis. And therefore, like, we would have the natural reading order. With these fuzzy space, with no alignment whatsoever, it's very much possible that no object in the board has the same vertical axis value as any object on the board. But we found out that relaxing a little bit the requirement of having the same vertical value kind of works in a satisfactory way. So we consider the objects aligned not only if they have the same value on the vertical coordinate, we consider them aligned if they overlap vertically. So if drawing a horizontal infinite line, we have two objects that are intersected by the line, then we consider those objects as aligned. And in this way, we can solve the natural reading order on this fuzzy space. Spatial navigation has yet another challenge of completely different nature. So here, we do not need to linearize the space because we want to look for objects in a specific direction, and therefore we stay in the 2D world. But here the problem is that we want to have the notion of the shortest distance in a specific direction. And the concept of distance, the most of us are used to, namely the length of the shortest path from the object, from one object to the other, does not take direction into account at all. So we need to modify the definition of distance in order to take direction into account. And luckily here, a little bit of math and trigonometry comes to the rescue. So we can use the angle between the desired direction and the direction of the distance vector from one object to the other. And we can use it to weight the traditional Euclidean distance. So the more the direction of the two objects diverges with respect to the desired one, the further away those objects would appear to the system. And therefore, this is how we solve the problem of finding the closest object on a specific direction. Now, we spoke about hierarchical navigation before, and how do we do that in our space? We don't have any headings, we don't have any titles, but we do have something that conceptually speaking provides hierarchy to the boards. And these things are container objects. In particular, we've got a type of object, which is called a frame, which acts as a container for other objects. So we decided to use those containers to provide hierarchy to the boards. And in navigation, they would be considered as just one object, no matter how many objects they have inside of them. And in order to access the objects inside of a container, one would need to trigger a specific keyboard shortcut that gets into the container. And then at that point, only the objects inside of the container would be available. So this really follows. Probably the closest analogy is the behavior of a file manager, such as Microsoft Explorer or Apple OS, like Apple Finder. So the file managers, where we navigate into a folder, and then we can see only the content of the folder itself. So here is a video about the concepts that I just described. There are some widgets which are grouped into frames, and there is a virtual keyboard that shows the keys that are pressed. So by going to the first widget and then pressing the tab key, the widgets are navigated, like the frames, the containers are navigated in a linear fashion using the first strategy that I just discussed before. And then by using the command plus arrow keys, the spatial navigation is activated, and therefore we can select the object that goes to the left or to the right or to the top or to the bottom of the current one. And then in order to access the contents of a specific frame or a specific container, we can press the command plus shift plus down arrow key. And at that point, the same linear navigation strategy and the spatial navigation strategy will be available, but just for the frame, just for the objects which are inside of the container itself. Then one can press the command plus shift plus up arrow key, and that would go out of the container itself. And now we can navigate again at the top level as we were doing before. Now, keyboard accessibility is a fundamental aspect of making the product more accessible. It makes the widgets more operable following the WCAG principles. But for people with visual impairments or low vision, no vision at all, we must do more than that. We need to make the widgets and the objects on the board also more perceivable. So we need to basically transform all of the visual information that we have on the screen into some sort of representation that can be consumed by people that cannot use vision to consume the information. And we are planning to use to support several assistive technologies in the future, but for the moment, we are focusing on screen readers and basically transforming all of the visual content of our Miro boards into text for screen reader announcements. So screen reader users should be able to perceive at least relevant information for the objects that are navigated by them, so the objects that are selected by the user itself. They need to know their own actions on the board. So when they create widgets, delete widgets, or edit content on the board. And then since our tool is a collaborative one, the collaboration aspect is very, very important. And therefore, also the action of collaborators should be notified. We tried a couple of approaches. The first one, we tried to create sort of a hidden DOM for every object on the board. So basically every object on the canvas, for every object on the canvas, we made a shadow HTML object containing the semantic information to be consumed by the screen reader. It's like the advantage is it's a declarative approach. So the screen reader pulls the information from the page itself. All the information that's needed is declared on the page, and the screen reader does the heavy lifting of actually creating the messages. And basically, the board becomes a standard web content. So we can use standard definitions and practices for web content. Unfortunately, the disadvantages were blockers for us. So the minor of them all was that the announced text may be different from screen reader to screen reader. So it's really dependent of the various implementations. JAWS works a little bit different from NVDA, which works a little bit different from VoiceOver, and so on and so forth. But the most important part is that it gave very, very poor performance as the board grows in size, because at that point, we would need to update dynamically and maintaining a DOM of thousands or tens of thousands of elements, and that just wouldn't cut it. And then another blocker was that screen reader announcements using the hidden DOM heavily relies on focus management of such elements to provide the announcements, which means that it was very, very difficult to capture the collaboration from other users, because those would be events that would not change the focus on the elements themselves. So we took another alternative. We tried the use of a live region. So the idea is to have just one single HTML element using the ARIA directive live region, which would make that element observed by the screen reader for changes. So the advantage is that now we can also respond pretty easily to collaborator events. We can also use different priorities for announcements. So we can have the assertive announcements that are very important and urgent. And so they are immediately announced by the screen reader, maybe interrupting other things. Or we can have the polite ones that just wait for the screen reader to finish the previous announcement before saying the new one. And then the nice thing is that the behavior of such strategy is almost independent of the screen reader implementation. It doesn't require focus management, and it doesn't degrade performance as the board grows in size. The cons is that it's not declarative anymore. So it's the developer's responsibility to actually provide good quality and relevant announcements. So in spite of the disadvantages, we chose the live region because it allowed us to have this uniform handling of users and collaborators announcements. And then the fact that we are not touching focus management also plays nicely with other features that are already implemented in the board, such as immediate typing, which is a feature that allows to immediately type text on a widget without entering a particular and specific text editing mode. The text editing mode activates the focus on a hidden HTML input element. Immediate typing always keeps the focus on the element itself, and therefore it wouldn't play nicely with changing the focus to trigger the screen reader. Another thing that we needed to do from scratch would be to provide alt text for images into the canvas, because the images in the canvas are not image tags, and therefore that feature would also not come for free. But accessibility is much more than just keyboard and screen reader navigation. A few more things that we did in our initiatives. We implemented a reduced motion mode or preference, so that the board, unwanted and unneeded animations on the board would not be played. And this is very, very important for those people that suffer from motion sickness by looking at monitors with many, many animations, or maybe suffer from distraction from their focus whenever they see something moving a lot. Another thing that we need to accommodate for is color blindness, or reduced perception of color, because 1 out of 7 men and 1 out of 200 women suffers from some sort of reduced perception of the color. So what we did is to provide a tooltip on every color picker, having a textual representation of the color that is chosen, so that users will be able to know what color they are assigning to objects and what color is assigned to a specific object. And finally, the last two features that I want to present to you, it's the comment palette. So this is a menu that mimics what screen reader users are very much used to, which is a shortcut that activates a drop-down menu that provides the most important actions that can be done on a board. It's sort of a one-stop shop for actions. And this is, in my opinion, one of the best examples of what Phil was mentioning before. Designing for accessibility creates the opportunity of building such tools which have a huge impact, not only for people with disabilities or people who actually need them, but also for like every user in general that gets such a powerful way to interact with the board in a different and more efficient way as before. Finally, always talking about color, we implemented the possibility of changing the background color of the boards. This is something in between accessibility and aesthetics, because it's just a cool thing to have, but at the same time, it's also a very powerful way to increase the contrast of the objects against the background by just choosing the right background for the content of the board that we have. So in these few minutes, I talked about how we implemented and took inspiration from standards and guidelines about interacting and navigating through web content, and adapted them to the HTML canvas and to the Miro case in particular. But what can we do about the collaboration aspect? Because it's not so much regulated yet. So for that, I would like to pass the mic again to Phil, that has something to say about inclusive meetings and the research we're doing on those.
Thank you, Stefano. Yes, that's 3 really great examples of how, considering the needs of people with disabilities can create experiences that are really great for everyone. And so at Miro, we also recognize that just like on the web, where it's totally possible to create an inaccessible experience, even though we've had lots of guidelines and lots of accessible native HTML elements. We all also recognize that no matter how much we try to make Miro accessible, there will always be a reliance on meeting facilitators to create accessible and inclusive collaborative meetings. So therefore, we wanted to understand better, how we could create these accessible, inclusive, collaborative meetings. So we commissioned user research with a company called Open Inclusion. And so what we did, we took a user research informed approach. We conducted in-depth interviews with expert users of collaborative whiteboards and people who would work with, for example, charities who would employ people with disabilities to understand how they created these inclusive environments. And then we validated the findings that we got from that with 3 focus groups that had 18 users. And everyone who took part in this research identified as either having a disability or an access need. And so what came out of this research? So we had kind of 4 different categories of recommendations. So things that you can do at any stage. So considerations throughout the collaborative session design and delivery for greater inclusions. So what can you do before a session to make it more inclusive? What can you do during the session? And what can you do after the session? And so I'm just going to highlight very briefly some of the key findings from this research that we came up with. So considerations to apply at any stage. So recognize and share the value of inclusive collaboration, understand the importance of inclusion, be accountable for it, and share the benefits with other teams. Be intentional and open about inclusion objectives. So set expectations, share your intentions, and draw in those with experiences and skills. Ask and don't assume regarding relevant needs. You may or may not know the needs of those joining the session, so don't make assumptions. And then with consent, remember relevant preferences. If running multiple sessions, remember access needs and preferences, and always remember that you may need to ask for consent before recording any personal information. So be adaptive and creative. You may need to provide more time for inclusive considerations. It may take longer to plan, and be prepared to adopt an alternative plan. Offer alternatives to all and consistently learn and share principles, experiences, and progress. So what can you do before the meeting? So yeah, objective-led meeting design. Ensure you have very clear aims and objectives for your meeting. Understand your participant needs. Hybrid meetings are really important to ensure that you consistently incorporate contributions from both those inside and outside the physical room. There's various recommendations that we provided around how you can prepare and design a board for collaboration. So consider things like, color contrast. Stefano mentioned a way that you can structure a board to ensure frames that will make it easier to navigate around the board. So there's lots that you can do to create an accessible experience through the board itself. And then pre-meeting communications, communicate to participants ahead of the session to make sure everyone attending has the agenda. So I just want to highlight understanding participant needs is absolutely critical to the success of creating an inclusive meeting. So ask in advance if people have access needs or adjustments, and consider and recognize those needs where the access needs may clash or contradict each other. And then explore access needs with relevance to the use of a visual collaboration platform such as Miro. So as I mentioned, just make sure that you have put all the kind of different things in place to make the experience as accessible as possible. So during the session itself, we've divided these guidelines up into facilitation and collaboration. There's lots of things that you can do during the session, such as providing closed captions, offer alternatives to a chat function, manage good turn taking, and again, providing accessible content. And then after the session, provide time at the end for contribution and make sure you share the outputs in an accessible format and gather feedback and consider it. So just in a matter of time, I went through these guidelines very, very quickly. But what we've done, we've put together all the findings from this research, and we've created an ebook that we call 10 Principles for Inclusive Collaboration. And if you go to miro.com accessibility, you can download our step-to-step guide to learn how to prepare for, facilitate, and operationalize inclusive meetings and workshops. So just kind of to wrap up, so what we've covered is we've talked about the context for compliance and sustainability. We've outlined 3 ways in which we're innovating in the accessibility space, and we've looked at different ways in which you can create inclusive collaborative meetings. So what's next for Miro? So as I mentioned just there, we're looking at ways to make it easier to create accessible boards. So we're going to provide an automated checker so that you can determine whether or not, for example, color contrast is available. We're exploring the use of sound to convey information. So both Stefano and I have a background in sound design, so we're very excited by the opportunity to use sound to convey information, especially in the collaboration space. And then another thing we're looking at, artificial intelligence is a big thing today. So we're looking at ways, one exciting project is that can we use the visual Gestalt principles of design to provide a more useful clustering experience to allow users to navigate through the board more quickly. And just the most important thing is that we want to bring all of you along on our accessibility journey. I think in the accessibility and disability space, the statement "nothing about us without us" is one of the most important principles. And so what we would really appreciate is your feedback and just your taking part in any public betas that we might come up with as we progress in this journey. And so in order, if you're interested in finding out more about our accessibility efforts or you want to get in touch, you can visit miro.com/accessibility or contact us at accessibility@miro.com. So thank you very much for taking the time to allow us to share our approach to accessibility at Miro. So thank you.
G. Oh, hi. Sorry about that. I was muted. I'm back. Thank you, Phil. Thank you, Stefano. We have quite a number of questions in our chat. I am going to take the first one here. Since Miro is also an authoring tool for collaboration, it seems like a lot of the barriers to accessibility depend on who's authoring the content and how it is created. In other words, the heading structure, good alt text, clarity, and tasks. Have you looked at addressing accessibility on the authoring side, or these other kinds of challenges that might be less of a technical nature?
Yeah, this is a really great question, and that's what I was alluding to in the last part of the presentation. So in order to address that, there's three different things that we've done. So the first is that we have provided our inclusive meetings kind of book that you can go in and read about how to create these inclusive collaborative meetings. In the second part, if you go to miro.com/accessibility, we provide specific guidance on how to create Miro boards for accessibility. And so that includes things like, color contrast, same as on the web, you want to make sure that you're adhering to the W3C WCAG 2.1 AA color contrast guidelines for content. And then other things like creating frames and creating a good structure, other things that are exactly the same as you might get on the web. And then the final part is that in the future, we want to introduce this automated accessibility checker that, like any automated tool, it can only go so far, but it can always at least provide a reminder. I think it's really interesting, if you look at other tools, for example, providing alt text for images. We heard that, for example, on Twitter, whenever they provided the ability to add alt text to the images, there's a really super low uptake. So there's lots that we can do to nudge people towards increasing the awareness that there is that as an option as well. But this will always be a challenge with any creation tool. We will always need to make sure that people are aware of and are able to do what's necessary to create accessible content.
And I would like to add a very, very quick word to that. In addition to that, we're also making sure that all of the defaults that we provide in our authoring tools, so whenever you create a sticky note, whenever you create text, whenever you create an object on the board, all of the board defaults are carefully curated in order to already respect as much as possible, at least the contrast ratios and everything, which is good accessibility practices.
Thank you. There's another question here that I really like. If you had a magic wand that meant you could improve Miro's accessibility with no cost implications, financial time, whatever, what improvements would you two personally want to include?
Yeah, I can go first here because the first thing that comes to mind, and it's related to this idea of, Miro is an unlimited open whiteboard, and, we've seen boards that have thousands upon thousands of objects. And, for me personally, I think looking at being able to summarize the content, to be able to get a really good overview of what a board contains, so that then you can decide where you want to go, how to navigate around the board. So I think just being able to provide more structure to the content and providing the tools for users to be able to navigate through that would definitely help me personally with some of the boards that I've interacted with in the past.
I will answer probably in the most egoistic way as possible, but as a sound designer myself, what I would probably do would be board zonification. So the use of auditory icons to provide information about collaboration, about everything that happens on the board. Having a board that sounds, I think it would be just an amazing experience. But at the end of the day, I wouldn't know because I don't want the magic wand to do that. As an engineer, I want to do that myself.
All right, thank you for that. Let's take one more. So this one is about how do you assess and incorporate accessibility in terms of how a board is used? For example, templates for horizontal navigation rather than lots of diagonal jumps. I've met neurodiverse people who struggle with this in Miro and in Neural. Interesting use case.
Yeah, so I guess it's talking about how do we, kind of assess, incorporate accessibility in terms of how a board is used, templates. So yeah, I think there's lots that we can do, to ensure, as Stefano mentioned, that the defaults that we create are accessible, and maybe we could, kind of highlight specific, kind of templates that are more usable for different, populations. So I think again it comes back to Miro is such an open canvas. There's so many different possibilities and lots of different things that you can actually do. So I think it just comes down to providing lots of guidance, and user research as well is absolutely critical to understanding the experience that people have with whiteboards, and then our collaboration tools, and then providing the guidance and the feedback to board creators so that they can incorporate that.
Awesome, thank you. We have, I think, time for one more question. Let's see what else there is. And one thing, while I was on mute, my apologies for that. What I said was Phil and Stefano agreed to follow up with questions that we don't get to here, that we will post to the event page so that you can follow up with that. Here's our last question. Is there any guidance that you can offer on how to access Miro with different assistive software? So for instance, Dragon, a list of what commands will work, or JAWS, how to navigate. How would you answer that one?
Yeah, that's definitely something that we want to do and provide on our website at miro.com/accessibility. So the challenge that we've had up until now, that we've been continually developing the support for the assistive technologies, and so we're at the stage now where we have unlocked access for different types of assistive technologies, and so the next step for us is to provide the documentation. So I would say, yeah, go to miro.com/accessibility, and we will provide this documentation over time.
Thank you both. You've been incredible bringing all of this to all of us here and sharing it with us so openly. Thank you everyone for attending. We hope you have a lot of fun at the rest of AXCON. See you in hopefully one of the next sessions. Take care, everyone.